Hello everyone. Today in this we are going to discuss about charging data record. You can find it full course on telecomglobal.com. So charging data record in telecommunication. So before that let's understand some basic concepts. So what is billing domain? So this is a part of the operator network which is outside of the telecom network. It receives and processes charging information from the core network charging functions. It includes functions that provide billing mediation and billing or other function, for example, statistical and applications. Next we have charging. Function with the telecommunication networks and the associated OCS or BD components, whereby the information related to chargeable event is collected, then it is formatted, after that transferred and evaluated. Why? In order to make it possible to determine usage for which the charged party may be billed or the subscriber account balance may be debited or credited. This is charging. Next is CDR, which is charging data record. It is a formatted collection of information about one or more chargeable events. For example, time of the call setup, duration of the call, amount of the data transferred, etc. This is for use in billing and accounting. For each party to be charged for parts of all the charges of events, a separate charging data record is generated. That is, more than one CDR may be generated for a single chargeable event. So because of its long duration or because more than one charge party is to be charged in this. Then we have charging function. Entity inside the core network domain, subsystem or service. It is involved for charging. Circuit switch domain like CS, GSM, UMTS. Domain. Domain is a part of a 3GPP telecom network. It provides resources for a technology. Middle tier TS. It is a term which is used for 3GPP charging telecom standards. They specify domain, subsystem, service-specific online, offline charging functionalities. Other than this, we have non-real-time also, near real-time. Near real-time charging and billing information is to be generated, processed, transferred to the desired conclusion in less than 1 minute. We call it as near real-time. So this is logical offline charging architecture. We can see CTF, CDF, CGF, billing domain. These are the interfaces. Now, what is charging data record, file transfer principles and scenario? Here we have CDR processing. So, scenarios as local CDR and CDR file handling, file format principles, file transfer and transport and protocol, and transfer modes and session management. Each of these scenarios we will discuss in our classes and this course of CDR. So let's start with local CDR and CDR file handling. Under this we have CDR processing. Now what happened? The CGF collects CDRs from the CDF. The CGF here. The CGF collects all the CDRs from the CDF. If the CDF and CGF are separate entities, then the standard GAA interface is used to transfer CDR from CDF to CGF. The possibilities of separate and integrated CDF and CGF are specified per domain. Subsystem and service with respect to middle tier charging telecom standard as we have discussed. If the CDF and CGF are integrated, then the internal mechanism is used. Once received by the CGF, the CDRs may undergo semantical and syntactical sanity checks. CDF is what? CDF is combined distribution frame. Now in any case, CDRs are transferred in near real time from CDF to CGF as soon as they have been closed by the CDF. CGF as charging gateway function. Now, if the CGF gateway function determines that a CDR is not well formatted, if it checks, or otherwise if it checks that these are not, gateway will check that the CDRs are incorrect, then the defective CDR parameter shall be filled with an appropriate replacement indicator within the limits of syntax which are allowed for all the parameters. Now, CDRs that have been processed by the gateway function CGF without error or where errors have been corrected by the gateway function are acceptable. The acceptable CDRs are immediately placed into a CDR file by the CGF. The CDRs that are not acceptable should be properly reflected in an error log. An appropriate alarm should be generated, after which they may be destroyed. It is acknowledged that the processing of a CDR being received until it is placed on a CDR file. That means all acknowledgement should be there until the CDR should be placed on a file. Hence, where the here should be immediate treatment of the CDRs which are received by the CGF. They should be interpreted such that it is not allowed to postpone the processing of the received CDRs for any reason. Next, we have CDR routing. In the default mode of operation, the CGF gateway function manages a single file for the storage of all acceptable CDRs. However, the CGF may also route CDRs to different files. They are kept open concurrently. That means additional files may be configured by O&M commands together. The CGF gateway function stores only CDRs which are matching with the associated filters on each additional files. So the file name shall, within the limits of the convention, shall an indication of CDR routing filter applied. Local CDR file management. Several conditions may govern the closure of the CDR file by the CGF. The CGF which provides a non-interrupted chain of the files. Each CDR is immediately stored in the appropriate file after being received and acceptable. So, for acceptable, a configurable file size limit should be there, a configurable file closure limit, a configurable file lifetime, which is known as interval, a configurable number of CDRs within the file, manual actions, and system defined read. When a CDR file is closed, the next matching CDR shall be placed in the next file in the chain. Next, we have file format principles. The CDR files may contain a variable length header section followed by the variable size CDR data section. The CDR data section contains 0 and more concatenated CDRs. Each CDR in a file includes a header. Header includes a CDR length, data record format, release version, and its encoding scheme. So this is the file format and the CDR that we had discussed. Thank you.